Hey everybody, this video is all about how to tell if a system is isolated, which is the same thing as how to tell if energy is conserved with an N. So that's what that means. And I know this unit, we're saying energy is conserved all the time. However, you will get questions from time to time, maybe on a quiz or a test, asking you, is energy conserved here? So here we go. We've got the bike rider and his bike right here. And they have a combined mass of 75 kilograms, 75.0. Assuming the rider does not pedal in the maximum height at point 4, which is up here, is 12.2 meters, is the system isolated from the environment? So the first thing, I already started, you can tell with the guide, but the very first thing that we're going to do before we talk about the guide is write down the different forms of energy. So one thing that we're going to do here is we're going to use this line here, okay, the ground as H equals 0. Well, that's a funny H, but whoop. H equals 0, super. That doesn't look great, but oh well. Okay, so we're going to say that this guy, since he's on the ground, doesn't have any GPE. He only has KE. So we're going to label that. I wanted to do this on my iPad because it's easier to write with my finger, but I forgot that at home today. And then we're going to look at point 4 because we just need to know point 4 and pretty much point 1. I'll talk about why we're doing point 1. But anyway, so up here, this has 0 meters per second, but he's 12.2 meters above the ground, so he has GPE. Okay, thank goodness that's over. So the reason I use point 1 is because it has KE only. Down here, we don't know the height, like how far down. I took this diagram from a question that asked all sorts of things. And so anyway, one of the questions is how far below the, ground does this guy go? I'm not really sure where he's going, but anyway, like why he's going beneath ground level, but that's fine. And then, so we can't use that one because we don't know the GPE there. And then up here, we could use this, but I just don't want to calculate the GPE plus the KE. This is easier. So here's what we're going to do. So for the guide, I set it up so we're going to compare 1 and 4. So I wrote down all the stuff. I wrote down that V1 equals 16, H1 equals 0. The mass was 75.0 that was given. V4 equals 0, H4 equals 12.2, and G equals 10. And remember, we don't use the sig figs from G equals 10. What they're asking us is basically, does E1 equal E4? Well, that's they do say, so I guess I should add, is energy conserved? Is system isolated? So really what they're asking is the total energy equal? And we're going to use E1 for the reasons that I stated. So anyway, then I wrote down the 3 things we need. GPE equals MGH, KE equals 1/2 MV squared, and E total equals GPE plus KE. So let's get going. We're going to talk about E1 first. And I'm not going to use a table in this one, mostly because we just use tables when we know that systems are isolated. And here we don't know that. So I'm going to write down EPE1 equals GPE1 plus KE1. Sorry, E1. And we're just going to calculate that. We know GPE is 0. So we're going to write 0 plus, let me see, it's probably easier for me just to copy and paste this. And what I can do here, 75, so the mass is 75.0. Hello. And then we're going to multiply that by 16. Whoops. Well, now I lost the squared, so I'll just write caret 2. Oh, look at that. It knows it. Okay, cool. All right, so that's going to equal, well, I should have done this, but I forgot. Well, I'll pull up my calculator. Look at that, friends. We all have calculators. So anyway, I'll do 16 squared first. I'll divide that by 2, and then I'll multiply that by 75. It's going to be a big number. So we got 9,600. 9,600 joules. And I'm not going to worry about sig figs right now. I will if we get something weird for E2 or something close for E4. So now I'm doing E4. Oops. And that equals GPE4 plus KE4. Okay, so we've got E4 should equal, so we're going to do our GPE4 will be our M 75.0 times our G, which is 10, times the height, which was 12.2. And then the KE is 0. Okay, so now we're going to go through again. We're just going to do 750. Yep, hide tools, get out of there. Times 12.2. I did 750 because I know that 75 times 10 is just 750. So we're going to get 9150 joules. Okay, so our answer is going to be no. The system is not isolated because E1 does not equal E4. Okay, so we're comparing those two numbers. I'm going to slide down here. We get E1 is 9,600, E4 is 9,150. So somehow we lost 450 joules. When things are like this, energy is removed. So what we might think in order to, it specifically says that the rider does not pedal. So in this area of saying energy is always conserved, what we're going to say is probably it was something that the human did. So my guess is that the human at some point hit the brakes because that would remove energy from the system. I don't know where, but at some point before they left the ramp, because if they hit the brakes in the air, it doesn't matter. Then they lost some of their energy. Once we start talking, and in real life, you can probably think, okay, air resistance, friction, all sorts of different reasons. But right now we're talking about energy should be conserved, so it was probably the human's fault. So we might say the bike rider probably hit the brakes at some point before he left the ramp. I don't know why it's he, but it is. Okay, this could even so this can be part of your E explanation. The bike rider probably hit the brakes at some point before he left the ramp. If E4 was bigger than E1, that would be weird because it says that the rider doesn't pedal. What would add energy? I mean, maybe a huge gust of wind, but that's probably not very likely. All right, so that's how you do it. You find the energy at one point, you find the total energy at the other point, and you compare them. If they're equal, the system's isolated. If they're not equal, the system is not isolated.